This is a real quick video on some basic addition facts with mathematical rational expressions where we're adding, subtracting, multiplying, and dividing rational expressions. A rational expression is just an algebraic expression written as a fraction. So in this first one, remember, in order to add fractions, you have to have the same denominator. So since my denominators are the same, I can just add the numerators, and so that would simply be 3 plus m plus 2n all over 30 n to the 5th power. This one I have the same denominators, so I can just add. So that would simply be 6 plus u minus 6v over 16 uv. This one down here I have different denominators. This is 3y squared, this is 2y cubed. I need to have a least common denominator, so I need to find the multiple that both of these will go into. So the smallest number that 3 and 2 will go into is 6. So what I like to do is I like to write this like this: 2x over 3y squared plus 6x over 2y cubed. And 6 is the smallest number that 3 and 2 will go into, and I need a least common denominator that y squared and y cubed will go into, and that would be simply y cubed. So what do I need to do to multiply this by to get that? I need to multiply it by 2y. So if I multiply this by 2y, I get this. So I have to multiply the numerator by the same thing. So in essence, I multiply this by 2y and this by 2y. So that's going to be 2xy. And this I need to multiply by 3. So that's going to give me 18x. So now the denominators are the same. I can add the numerators. These are not like terms because this one has a y in it. So that would be, my answer for this would be 18x plus 2xy all over 6y cubed. Looking at this next problem, this is a multiplication problem. When you multiply fractions, you do not need a least common denominator, so you simply multiply the numerators straight across, denominators straight across. So simply 6 times 9 is 54 over 28x to the 4th power, 28x to the 4th power. And as you've always been taught, you need to reduce all fractions. So being that these are both even numbers, I can divide by 2. 2 is a common factor. So 27 over 14x to the 4th power. And that would be my answer. Now, if you want to reduce first, you can do that. The 6 and the 4 could have been reduced by 2, made that 3 there and 2 here. And then when I multiplied 3 times 9, I get the 27, and the 2 times 4 gets a 14. So you can reduce first or after. I would always encourage reducing first. Here's an example of a more complex multiplication problem. It's already factored for you, so if there's any common factors, they can be canceled. It doesn't matter if it's in this fraction or this fraction. So this x plus 5 in the numerator divided by x plus 5 is 1, so they cancel out. This k minus 7 in the denominator here and this k minus 7 in the numerator there, because it's multiplication, can get factored out. This k here, and this is k squared, so I can cancel 1k out of here and 1k out of there. So if I cancel a k out of there, I just leave me with k instead of k squared. So what's left is 10 times 10 is 100 over 7k. Last thing I look at is, can I reduce that? And I can't. 7 does not go in 100 evenly. This one here, don't see any common factors, but this is factorable. So the first thing I'm going to do is I'm going to factor this. I have 1 over k plus 4 times a common factor is 2k. So if I factor a 2k out, it's just a distributive property, I would have k plus 4 That's over k plus 10. So being it's multiplication, if there's anything in the numerator of one fraction or the same fraction and the denominator, I can cancel those. So this k plus 4 divided by k plus 4 is 1. That cancels out. The only thing I have left over is 2k over k plus 10. A common thing people want to do is they see that k there and that k, and they are tempted to cancel those k's. You cannot do that because each of these terms would have to have a k in it. This 10 is being added to that k, so I cannot cancel those k's. Okay, next we move to a division problem. You've been taught a long time ago when you are dividing fractions, you reciprocate and multiply. So I'm going to make this 10n squared divided by 2n times 4 over 5. Okay, then I could simply multiply. So if I multiply, you got 10 times that is 40n squared over 10n. Last thing you do is reduce. Of course, 40 and 10 reduces. I can divide that by 10, so that would just give me 4. And n squared divided by n, I can cancel this n with one of those, so that would just give me 4n. Now, I could have reduced first. The first thing I could have done is I could have made this simply, looking at the original problem, 10 divided by 2 is 5, and n squared divided by n is n, so that'd be 5n times 4 over 5. And then those 5's will cancel. The only thing I'm left with is n times 4 is 4n. So reduce first if you can, or reduce at the end. All right, this division problem. Is there anything I could reduce? Anything on top with anything about them? No. So I follow the rule, reciprocate and multiply. So 10 times 7n minus 4 over n minus 9 times n plus 3 over 10 times 7n minus 4. Those 10's will cancel there. Those will cancel, and I'm left with in the numerator just n plus 3 over n minus 9. Lastly, this one here, follow the rule, reciprocate and multiply. So this would be x squared plus 6x plus 9 over 6 times 10x over 10x squared plus 30x. Okay, now I'm going to factor. This can be factored, this trinomial. What two numbers multiply together give you 9, but add together give you 6. So that would be x plus 3 times x plus 3 over 6 times 10x over, what do this binomial have in common? A 10 and an x. I can factor out a 10x. That would leave me with x plus 3. That's again just a distributive property, factoring that. So this 10x and this 10x can cancel. This x plus 3 here will cancel with one of those. And what I'm left with is x plus 3 over 6.